In 62 AD, a Greek engineer built a machine that should not exist. It used steam. It rotated. It harnessed power. 17 centuries before the Industrial Revolution changed everything. But this wasn't the only impossible technology the ancient world possessed. Hidden in the ruins of Rome, buried beneath Mediterranean waves, lost in the ashes of burning libraries, the Romans stood at the edge of technologies that could have reshaped human history. Steam engines that could have powered factories. Mechanical computers that could have processed data. Industrial chemistry that could have launched science centuries early. But these prophecies died with their empire. Forgotten, dismissed, abandoned. What if Rome had crossed that threshold? What if one brilliant mind had made the connection? And what if the empire had recognized what it held in its hands? What future did we lose in the ashes of antiquity? This is the story of Rome's lost prophecies. The technologies they almost built. The future they almost claimed. Alexandria, 62 AD. The greatest library in the ancient world stands at the edge of the Mediterranean. Inside its walls, the accumulated knowledge of millennia. Philosophy, mathematics, astronomy, engineering. Among the philosophers and mathematicians, one man sees beyond his time. Hero of Alexandria. Not a general, not an emperor, not a politician, an engineer, an inventor, a prophet of the machine age. Hero's notebooks contain over 80 inventions that seem to come from another era. Automatic doors that open when fires are lit on temple altars. The heated air pushes water through hidden pipes. The water's weight pulls ropes. The doors swing wide. Worshippers believe they've witnessed a miracle. Hero knows better. He understands pneumatics, hydraulics, the principles of pressure and force. Coin-operated machines that dispense holy water. Insert your bronze coin. A lever tips. Water flows. Ancient vending machines 2,000 years before their time. Wind-powered organs that play themselves when the breeze blows through their pipes. Each invention reveals a mind that grasps cause and effect. Input and output. Energy and transformation. But one device stands apart from all the others. One machine that holds the seed of revolution. The aeolipile, the world's first steam engine. It sits in Hero's workshop. A bronze sphere mounted above a sealed cauldron. Two L-shaped tubes emerge from the sphere's equator. Elegant, simple, deceptively powerful. Light the fire beneath the cauldron. Water boils. Steam rises through hollow mounting pipes into the sealed sphere. Pressure builds inside the bronze chamber. The steam has nowhere to go but through those L-shaped tubes. And when it rushes out, the sphere spins. Slowly at first, then faster, faster, faster still. Power from nothing but heat and water. Motion without muscle, without animal, without human effort. Hero watches his creation turn. He understands exactly what he's built. This isn't magic or philosophy or abstract theory. This is a machine that converts thermal energy into mechanical motion. The same fundamental principle that would power steam locomotives 17 centuries later. That would drive ships across oceans and revolutionize naval warfare. That would run factory machines and transform human civilization. The same principle that would end the age of muscle and begin the age of engines. Hero has discovered it in 62 AD. But in Rome, the aeolipile remains a curiosity, a temple trick, a clever toy to impress visitors and amaze the uneducated. Some temples use it to create mystical effects. The sphere spins, bells ring, worshippers gasp. The gods themselves seem to move the machine. Because Rome has something else, something cheaper, something more abundant than any machine could ever be. Slaves, millions of them, captured in conquest, bought in markets, born into bondage. Hero's prophecy goes silent. His steam engine spins in temples and workshops, seen by thousands, understood by few, developed by none. His notebooks are copied and filed in the Library of Alexandria. His knowledge sleeps among the scrolls, waiting for an economic system that values innovation over exploitation. But Hero's steam engine wasn't Rome's only glimpse of the future. Beneath the Mediterranean waves, another prophecy waits in the darkness. In April 1901, off the coast of Antikythera, a small Greek island between Crete and the Peloponnese, the sea is calm. The sun reflects off gentle waves. Below the surface, one diver finds something else. A shipwreck, 2,000 years old, scattered across the seafloor. Bronze statues, marble sculptures, pottery, jewelry, the cargo of a wealthy Roman vessel, lost in a storm millennia ago. Among the treasures, the divers find a strange corroded mass, green with age, rough, unremarkable to the untrained eye. They bring it to the surface with the rest of the salvage. The bronze cracks, pieces fall away, and inside the corrosion, something impossible appears. Gears, bronze gears, precisely cut, carefully arranged. First, no one believes it, but X-ray analysis in the 1970s reveals the full truth. Inside this corroded mass, over 30 bronze gears, differential mechanisms that won't be reinvented until the Middle Ages, epicyclic gearing that seems impossibly sophisticated. This is the Antikythera mechanism, the world's first analog computer, built around 100 BC over 2,000 years ago. Slowly, painstakingly, researchers reconstruct how it worked. You turn a handle on the side. Inside the bronze case, gears begin to move. Large gears turn smaller gears. Shafts rotate at different speeds. Pointers move across dials marked with astronomical data. And this technology was created around 100 BC, inherited by Rome when they conquered Greece and absorbed Greek knowledge. The Romans possessed this. They understood complex gearing, mechanical calculation, data processing through bronze and mathematics. This wasn't their only mechanical achievement. Their engineers built elaborate water clocks that kept time more accurately than anything that would exist for centuries. They created automated puppet theaters where mechanical figures moved through entire plays, driven by falling weights and clever cam systems. They built coin-operated vending machines for temples. Insert coin, receive holy water. Vitruvius, the Roman architect and engineer, documented gear ratios in his treatises, described cam mechanisms, explained feedback systems. The Romans had all the pieces, all the theoretical knowledge, all the practical skill. What if they'd pushed further? Imagine mechanical computers calculating trade routes across their vast empire, processing census data from millions of citizens, solving complex engineering problems for aqueduct construction. Imagine standardized calculating devices in every major city. No one asked, what else could this do? And so the knowledge remained frozen, until one day, the ship carrying an Antikythera mechanism sinks in a storm. The device falls into darkness, sits on the seafloor for 2 millennia. Meanwhile, across the empire, libraries burn. Alexandria burns in civil war. Irreplaceable scrolls turn to ash. The knowledge of centuries consumed in days. The prophecy of mechanical computing drowns in the Mediterranean darkness. Europe will spend over 1,000 years trying to reinvent what Rome possessed and abandoned. But there's one more secret the Romans nearly unlocked. One that would have changed everything. The Rio Tinto mines, southern Spain. Rome doesn't just dig holes in the ground. They engineer industrial extraction, hydraulic mining on a scale not seen again until the California Gold Rush. Their metallurgists master steel production, create sophisticated alloys, bronze for gears and mechanisms, iron for weapons and tools, steel for blades that won empires. They manufacture glass using precise chemical formulas, create pigments through controlled reactions, process millions of sea snails for a single gram of purple dye. They invent concrete that hardens underwater, build domes that will stand for millennia. The formula? Volcanic ash, lime, seawater, in perfect proportions, massive bathhouse heating systems, aqueducts moving millions of gallons daily, factories producing standardized goods. They organize supply chains across 3 continents, move armies of 50,000 men with mathematical precision. They have the mathematics, the organization, the industrial capacity. What they lack is the theory, the framework to systematize their knowledge. Their chemistry is empirical, recipes passed through guilds, secrets hoarded rather than shared. Imagine if they'd made the leap, from recipe to theory, from craft to science. Steam engines powering their furnaces, mechanical computers optimizing their formulas, chemical theory guiding their production, an industrial revolution 15 centuries early. Instead, the formulas are lost. The concrete recipe disappears for 1,000 years. Medieval Europe cannot replicate what Rome built every day. The prophecy of industry dies in the Dark Ages. Rome held the future in its hands. Why did they let it slip away? The answer begins with economics. Why build steam engines when slaves are cheaper? Why innovate when conquest brings endless labor? Abundance of human labor kills innovation. Then there's culture. Roman aristocrats prized pure thought, philosophy over engineering, theory over practice. The men who could imagine were not the men who could build. The men who could build were not given resources to imagine. There were no patents, no rewards for innovation. Knowledge was hoarded, not shared. A secret lost with one craftsman's death. Political instability shattered continuity. Libraries burned. Alexandria, Rome itself. Trade routes collapsed. Communication networks fractured. The connected world Rome built shattered into isolated fragments. Monks copy texts they cannot understand, preserving words without meaning. The prophecies sleep. For centuries, Europe spends 1,000 years rediscovering what Rome forgot. The steam engine reinvented in the 1700s. Mechanical computers reimagined in the 1800s. Modern concrete reformulated in the 1900s. We stand in Rome's ruins and wonder, what if one thing had been different? What if Hero's engine had been built at scale? What if the Antikythera mechanism had been mass-produced? What if Rome's chemical knowledge had been systematized? Would we be exploring the stars by now? Or would Rome's contradictions have destroyed them sooner? We'll never know. The prophecies died with their prophets. Rome's lost prophecies teach us something profound. Technology alone doesn't change the world. It takes economic incentive, cultural openness, systems that preserve and share knowledge. Innovation happens at the intersection of capability and necessity. Rome had the capability, but not the necessity. Their knowledge burned, but the questions remain. What other prophecies are sleeping in our own time? What technologies do we possess but fail to pursue? What will future civilizations wonder about us? The prophecies of Rome whisper across the centuries, not of what was, but of what might have been. Subscribe now so you won't miss the latest uploads.